I'll be talking about, as well as demonstrating, our project, that being a microcontroller bootloader written using Ada. While there are bootloaders written using Ada, none of them are open source. This is an issue for our sponsor, as one of Ada Core's goals is to increase the accessibility of the Ada programming language. They also want more projects which they can use to showcase the possibilities when using their Ada drivers library. The technical goals of our system start with the utilization of drivers written by Ada Core, as well as the creation of custom drivers if the need arises. Our system, when not influenced by the user, begins execution of a separate user code located somewhere else in the microcontroller's memory. If the boot process is interrupted, however, the user will then be able to use commands such as erasing programs, flashing programs into the memory, as well as verifying that those programs were flashed into the memory correctly. Our system is split into two major components. The first being the command line interface, which is the program that the user will interact with directly. It receives command from the user and communicates with the microcontroller using serial communication. When the bootloader receives the command and any other data it needs to do said command, it will perform the actual operations on the microcontroller. When the operation is complete, the bootloader will then send a success message along with any other data that the command line interface requested.
To demonstrate the system we've built, we'll be using our command line interface application to communicate with the bootloader to do various operations. First, we can receive some information from the board regarding things such as device and revision IDs. This information is stored directly on the microcontroller and will be sent back to the command line interface for the viewer to use when prompted. Next, in the case that a user does not know how to use a command, we can view the help pages that we've developed to help with that. In this case, we can explore how to use the flash command. In the flash help page, we can view information about the flash command, including a description of the command, the parameters that can take in, as well as the version history of the command. To exit the help page, we simply press the escape key on the keyboard. Back into the command line interface, we can call the clear command to remove any clutter in the command line interface. We can now execute the flash command by passing the flash command itself, a path to a binary file which we want to load into the memory, as well as the memory address that we want that program to be installed onto. The flash command will now begin reading the binary file, as well as erasing the programs that are in the memory before to make room to flash the new program. This will be based on the size of the binary file, as well as the memory address inputted by the user. Once reading the file and erasing the sectors are complete, flashing will now begin, loading the binary file into the specific memory locations. When flashing is completed, the program will now verify that the data has been loaded into the flash memory on the microcontroller correctly. When verification is complete, we know that the entire flashing process has been complete. To terminate the command line interface, the user can simply pass the quit command.